That's okay. The people on YouTube just missed our going over sine, cosine, tangent. If you need a review, it's over here. Oh, my screen's on a bit of a delay today. I hope that figures itself out. Okay, so Pythagorean theorem, Jared told me I need to use in order to find this missing side. Can someone set that up for me? How would I set up my Pythagorean theorem? Good. Whitley said 5 squared plus 3 squared equals x squared. Could I have done 3 squared plus 5 squared equals x squared? Yeah. Could I have done 5 squared plus x squared equals 3 squared? Could I do 3 squared plus x squared equals 5 squared? No. The only thing that matters to me is the hypotenuse is on the right side, and the other two can be in whatever order you want them to be. So let's start solving. 5 squared is 25, 3 squared is 9. Add them together, I get 34. And then I square root both sides. So radical 34 is equal to x. You will often get an ugly radical that we cannot simplify. It is not a whole number. That is an okay answer, and that happens a lot. So the hypotenuse is root 34. All right. Now we're going to do sine, cosine, tangent, etc. So who can tell me, now that we know all the sides, oh wait, before we do that, which is my opposite? Is it 3 or is it 5? Why is it 3? It's opposite of the angle. So in this case, my angle is down here. So my opposite side is across from it. So that makes 3 O, 5 is A, and then root 34 is H. All right, now that we've established that, who can give me sine?
3 over 34.
3 over root 34. Very good. Somebody else give me cosine. 5 over root 34. What about tangent? 3 over 5. Cosecant? Root 34 over 3. What about secant?
Root 34 over 5.
Root 34 over 5. And then what about cotangent? 5 over 3. Very good. Right. So we had to remember what all the trig functions were. We had to find the missing side, and then we just plugged in knowing our trig ratios and all of our side lengths. That was it. Questions, thoughts, comments? Doing okay so far? All right, we're about to do this 2 more times, but in a little bit of a different setup. On the first 2 that we did, I gave you the triangle and I labeled the triangle. On number 2, I'm going to give you just one of the trig functions. So I'm going to give you secant. If I give you secant, we got to fill that in on a triangle. What's secant the same thing as again? What over what? Adjacent. It's going to be hypotenuse over adjacent. So I'm going to go fill that in on a triangle. I have a nice triangle filled in for me. This is the standard form I was talking about on Monday online. So we're on like this XY axis. Whenever we draw an angle, we start on the positive X axis, and then I would go like around this way. Your angle though, and I don't think I mentioned this the other day, your angle is always close to the origin. So it's always wherever we are close to the origin. So if a triangle is not drawn for you, we're always going to draw it in this way, on an XY axis with the theta next to the origin. Not up in this top corner, down here. Okay, that's just kind of like process of how we do things. So I wanted to review that. If my secant is 3 over 2, hypotenuse over adjacent, I'm going to put 3 as my hypotenuse and then 2 as my adjacent. It's important and it matters that my 2 is this side, not the other side. We don't know my opposite side. So we got to find it. Can someone set up Pythagorean theorem for me? Perfect, Brooke. You could also do x squared plus 2 squared equals 3 squared. And then we start solving. That becomes 4 plus x squared equals 9. And then x squared equals 5. And then radical 5 is my x. Any questions so far? Okay, take a minute, fill in your trig functions because I'll need 5 people to help me with that. Mhm. Mhm. All right, you ready to go over them? All right, Troy, give me one of the trig functions. Doesn't matter which one. Which one does that go to? Sine. Good. Sine is radical 5 over 3. Good. L, give me another one.
Cosine
2 over 3. Very good. Parker, give me another one. 5 over 2. Good. Hadley, give me another one. So I can do cotangent or cosecant, and those are just the reciprocals of the ones they're across from. Very good for cosecant. Perfect. Awesome. For right now, you do not have to rationalize these. Do you guys remember what rationalize means? In a minute, I will make us do that. We don't, right now it's okay, your radicals in the denominator. I will make a distinct point when I want you to start rationalizing. All right, same idea for the next one. This time I've got tangent is 4 over 5. What's tangent again? Opposite over adjacent, good Kate, opposite over adjacent. So I need to draw a triangle and I need to fill that in. So I'm just going to draw a triangle underneath it. I'm going to do my standard form. It's on the positive x-axis. There's my 90 degrees. There's my theta. I'm going to label opposite as 4 and then adjacent as 5. And so I got to find my hypotenuse. We got to set up my Pythagorean theorem. Michelle, can you do that? Perfect. 5 squared plus 4 squared equals x squared. As long as the x squared is by itself on that other side, then it doesn't matter if 5 or 4 go in whichever place you want them to. 25 plus 16. I always have a hard time adding those together for whatever reason, but it's 41. And so my radical is radical 41. My hypotenuse is radical 41. And so now we use that to plug in all of our pieces. I'm going to find 5 new people I haven't talked to in a second to give me those trig functions. So fill those in. All right, we ready to go over them? All right, Becca, give me one of the trig functions.
Sine is 4 over 4.
Very good. Gabby, can you give me another? Good. Fisher, can you give me another? Cosecant? Or which one? The top one or the bottom one? Cosecant. Perfect. Quiva?
Secant is 41 over 5.
Perfect. And Lily? 5 over 4. Good. All right. So we were practicing those trig skills that we learned the other day. It's just in a couple different forms. I can either put it on the triangle for you, or I can give you one of the ratios and we can solve it pretty easily. Any questions or concerns so far? No. You guys are doing great. We're going to skip number 3 for right now because the sheet I just gave you is going to be a supplement for that. But I want to move to number 4 really quick because that's just calculator stuff. So if you're on that sheet, you're going to need to switch to the like scanned in version at some point because I only did a couple pictures on that one. So I want us to all get a calculator out. This is going to be a little tedious, but it's really important that we kind of go through this slowly because a calculator part should be like gimme points. Like we should be like, oh yeah, easy, easy, easy. Does everyone find where I'm at? So I just skipped over, just flipped the page. I'm on 42, it's at the top, and it's number 4. It says evaluate with a calculator. And then it says 10,000, which means 4 places after the decimal. And I'm going to pull in my little iPad calculator. I'm using something called Calculate 84. So if any of you need an iPad calculator, you can't use it during a test or quiz, but if you need it at home for any reason, it was a free app and it's, I think, pretty good. So we're going to use that. Okay, first thing I want to bring your attention to is your mode button. So I want you to click mode. It's the one next to your second key. And the most recent way I remember us using it is using parametric functions. So I made us like scroll over to parametric and we clicked on that. Remember doing that back in like unit 1 or 2, I think. What we're going to do now is the radian and degree line is going to be super important to us. So if we are plugging in a number that has a degree, then we need to press the degree button. That way both me and my calculator know I'm doing degrees. So like for letter A, that says 10 degrees. So I'm going to use the degree button there. If I have something with a pi, or if I have something like letter F with no degree sign, that's a radian. So that means I'm going to have to scroll over and make sure that the radian is pressed. So I always have had students in the past who are like, I don't know which mode to be in. Well, what are you putting in? If you're putting in degrees, you should be in degrees. If you're putting in radians, you should be in radians. It will not mess with anything else. You probably never thought about this mode before because like simple addition and subtraction, division, graphing, almost everything else you do in the calculator doesn't matter. We're just going to start pressing the sine, cosine, tangent buttons, and that's where this matters. So for the first couple problems, I'm going to be in degrees. So letter A and B are both degrees. So I'm going to make sure my calculator is in degree mode. So I'm going to go over to degree and make sure it's dark and selected. Once I've done that, I can get out of the mode by doing second mode, which quits me out of that menu. So now I'm back on my blank screen. If you notice, the only buttons I see are sine, cosine, tangent. There are no buttons that say cosecant or secant or cotangent. What we have to do is remember the relationship between those 3 that are not listed with the 3 that are listed. So like the first one I have is secant. There's no secant button here. What there is though is cosine, and cosine goes with secant. Remember they're across from each other on our little chart. They're all the reciprocal of that. So sine and cosecant are reciprocals of each other. Secant and cosine are reciprocals. Cotangent and tangent are reciprocals. And I'm doing this motion for a reason. Whenever we do reciprocals, we think about flipping a fraction, right? That's what I want to think about. Secant is the same thing as 1 over cosine of my angle. So whenever you see secant, cosecant, cotangent, we're going to flip it. We're going to do 1 over the thing that we can actually plug in. I can't plug in secant, but I can do 1 over cosine. So to do this, I'm in my degree mode. We just checked that a minute ago. So I'm going to do 1 over cosine 10. There's no degree button because I'm already in that mode. I don't need to tell it I'm in degrees because it already knows I'm there. I press 1 divided by cosine 10, and then I press enter. And I get 1.0154. That's it. 1.0154. I think I just said that backwards a second ago. All right. So again, secant, cotangent, we have to do 1 over one of the trig functions I can press. Someone in my last class was like, when are we going to press second? Not today. Second sign means that we're doing the inverse of sine, and that is not the same thing as the reciprocal of sine. So I'm going to be trying to be really intentional about what I say. Cosine and secant are reciprocals. They're not inverses of each other. Okay. Now let's do the next one. The next one says tangent. Okay, cool. We can just press the tangent button, but at least I don't know how to put degrees, minutes, seconds. You guys have fancy calculators. You might be able to do it. I don't know how to do that. So we got to make the minutes into a decimal. Good thing we practiced that on the board yesterday, right? It's all gone because Mr. Fogel used the board, or else it would still be up here for us to look at. Does anyone remember how I make that into a decimal? How do I convert 11 minutes into degrees? Divide by 60, good. 1 degree over 60 minutes, or as Al says, I'm just going to divide by 60. 11 divided by 60 is going, oh God, okay, please stop. Is going to be 0.18888 or 833333. You can put as few or as many threes as you want. 0.183. I'm having a hard time today. There we go. There's no seconds, so once I have that, now I'm just going to press in the calculator tangent of 28.1833 degrees. And again, it's not cotangent. There's a physical button that says tangent. It still says degrees, so I'm going to keep my calculator in the degrees mode. I'm not changing anything yet. And I'm going to do 28.18333. As many or as few threes as you want. And that's going to be 0.5358. Okay, so the work on the first one is I had to remember the reciprocal. The work on the second one is I had to make that minutes into degrees. Now the work on the second one is I have to do the reciprocal and I don't have a degree anymore, so I'm gonna have to change my mode. I'm gonna have to change my mode. Let's do that first. Let's go to mode and let's go to radians. How do I know this is in radians? What tells me that letter C is in radians? Got a pi, very good. Yeah. Are you in the degree mode? Okay, I'm gonna have to come look at you. Don't press anything else yet. What's cosecant reciprocal? What function does that go with? Sine. So I'm gonna do 1 over sine, and you can physically type 5 pi over 6 into your calculator. Again, make sure you're in radians. Oh, it's 28, not 20. Oh. I was like, really worried. I was like, is there a bigger issue we have here? That happens a lot, and there's a lot of place for mistakes. So just ask if you're like, I don't know if this is right, especially as we're doing these on the board. We want to find all of our mistakes now than on the test day. 1 divided by sine of 5 pi divided by 16, not 6, 16. That was almost another mistake. And I am in radians, so I just press enter, and I get 1.2027. Oh yeah, sorry, Bill. Are you in radians? Yeah. All right, let's go to the other side. Let's do 3 more. Okay. All right. Letter D says cosine of pi over 9. Oh, that's an easy one. I just have to press cosine. If you want to put that into degrees, you're welcome to, but I am already in my mode of radians, so I'm just going to type that in. Cosine pi divided by 9. And I get 0.9397. I can zoom all the way out in a minute, but I gotta keep it tight right now. I'm gonna skip the middle one, the sine, for a second, just because it looks like there's a lot of work there. Do you notice how cotangent just says 2 and it doesn't say a degree or anything and there's no pi? In that case, we recognize that it's a radian. So it doesn't have a degree sign, so that means it must be a radian. I know it doesn't have pi, and that's normally our Q, but that's okay. It doesn't have to. So I'm already in my degree, in my radian mode. I have not changed. I've been in here for a second. So I'm going to do, I can't press cotangent, so I'm going to do 1 over which function? Tangent, and then parentheses 2. And I get negative 0.4577. And so if this were on a quiz or a test, I would try and find, like, do all the radians maybe together and then do all the degrees together, so I'm not flipping, and then forget to flip one time. Or you can convert them all to radians, or you can convert them all to degrees. The next one, we have to do our minutes and our seconds into a degree before we can do anything else. So I will have to change my mode in a second, so I'm going to keep that in the back of my head. But I'm going to make my 18 minutes into degrees. So I do 18 minutes times what? 1 over 60. And that's going to be 0.3. And then I also have seconds here. I've got 13 seconds. So I've got to do my seconds conversions, which is 13 seconds times what? 1 over 3,600. Very good, L. Which is a big thing to divide by. And I get 0.00361. Now I have my decimals. I made my minutes and seconds decimals, but now I need to add them to the degree and add them together. And so I'm essentially doing sine of 129.3 plus the 0.0036 is going to be 0.3036. A little crunch there at the end. Don't forget to make sure you're in degrees. So before I do anything, I'm going to go make sure I'm in degrees. Unless, of course, you're converting a second time. And now I'm going to just press sine of 129.3036. And I get 0.7738. So some of them are really simple, like letter D, where I just simply plug in the calculator and I walk away. Or sometimes they're like letter E, where I had to put it into like decimal form for minutes, seconds, and then I have to put it in the calculator, and sometimes you have to flip it. Like there's just a bunch of things that we have to kind of keep in mind. The calculator stuff should be pretty simple and pretty self-explanatory, but it's easy to also mess up. So we're going to be careful. All right, I'm done with the calculator for now. Any questions on calculator problems? Okay, I want you to put this paper aside, and I want you to get the other additional paper I gave you in class. For those of us online, and even those of us in class who are doing it online, if you go to the Schoology page, there's a document that looks like this. It's called the unit circle. I don't think it's in any folder. I'll put it in a folder later today to kind of clean up the main screen, but it's just called PC Unit 4, or sorry, Chapter 4 Unit Circle blank. If you have that on your desk, just put that on the forefront. That the other paper we might get to, we might not get back to. And if you are doing this online, make sure you download this. All right, everybody got that? Okay, I want you to actually flip this paper over because we got to do a little pre-work before we can do actual work. So the pre-work we need to do is, first thing I want to do, this is going to be like a big reference sheet. Not necessarily something I'm going to like let you use on quizzes and tests, but it's good for homework. It's good for as we do other problems. It's good to just have the sheet kind of out and about with us. So the first thing I'm going to remind myself is my SOHCAHTOA. So on the back, like right about here, I'm just going to write SOHCAHTOA and my sine, cosine, tangent stuff. So SOHCAHTOA. And I'm going to write it all nice and neatly. I'm going to do sine of theta, and then I'm going to do cosine of theta, and then I'm going to do tangent of theta. I'm going to do cosecant of theta, secant of theta, and then cotangent of theta. We're making like a nice pretty box essentially. Again, we want our reference sheet to have as much information as we can on it. You can draw a triangle next to it if you want, but I think it's easiest to just remember like what our ratios are. So we know sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent, and then we reciprocal all of them. Everybody good so far? Hanging in there? Good. Cosecant is hypotenuse over opposite, secant is hypotenuse over adjacent, and cotangent is, nope, adjacent over opposite. Okay, so I know we've already gone over that, so you might be like, okay, yeah, we know this. I maybe didn't even need to write that down. The next thing was taught to you back in geometry. So I had many of you in geometry, so I know that you learned this. However, I know that there's other things that have been put in your brain since this, so I know that we might not remember it. We're going to go over the special right triangles. So I'm going to write special right triangles, and I'm going to have 3 columns on this page. So I'm going to make like a little line here, and then another one here. That might be a little too far. There were 2 special triangles we learned about in geometry, and the only reason I have a 3rd column is because the second triangle you can flip 2 different ways to look at. So the first one is going to be our 45, 45, 90 triangles. So I'm going to draw a triangle that is an isosceles right triangle, essentially. I do want us to be particular, and I want the like corner of the triangle to always be on the left, and then like the right part of the triangle to always be on the right. I know it's kind of a particular silly thing, but I want it that way. And these are 45, 45, 90. They look like this. We'll fill that in first, but let's keep doing the other triangles. The next one is 30, 60, 90, and we're doing it twice because you could either focus on the 30 or the 60. So on this one, I'm doing the 30 is going to be the angle that's in the bottom left. And the 60 is up top. And then now I'm going to draw this exact same triangle, but I'm going to flip it so the 60 is in the bottom left corner instead. And I'll try and make it more exaggerated. Again, the last 2 are the exact same triangle, but it's important to know what your area of focus is. And the area of focus is the angle that's in that bottom left corner. All right, do you kind of remember the special right triangles, spending a little bit of time, 45, 45, 90, does that ring any bells? 30, 60, 90, does that ring any bells? Okay, along with each of these triangles, we had kind of a general form or like a general side lengths for them. In a 45, 45, 90, the 2 sides across from the 45 are the same length. So we're just going to call them both 1. I think we called them X before. We called them XX. And then the last side was a funny one. It was X root 2. Or in this case, we're just doing the most basic. So we're doing 1, 1, and then root 2. Every 45, 45, 90 triangle is this form. The 2 sides are the same, and then the hypotenuse is root 2 times the side length. So now that we have this, we're going to do sine, cosine, tangent, cosecant, secant, cotangent of all of these triangles, okay? So let's fill that in. So I'm going to do sine, cosine, tangent, and I'm going to do cosecant, secant, and cotangent. The ones I really care about are sine and cosine. That's the whole reason we're doing this. But in order for us to fully appreciate the front side of this worksheet, we need to remember how like special right triangles work. Technically, the 45 is either one, like adjacent and opposite don't really matter here because they're the same, but we're going to keep sticking with like my focus is the bottom left corner. So my opposite is this one, my adjacent is this one, and then my hypotenuse is my root 2. And so now we're doing our trig functions, which we've just practiced a few times. We're going to fill in sine, cosine, tangent, and then flip them. So what's my sine of this group?
Now this is the moment where I want us to start rationalizing. So I said it was okay a minute ago.
And I'll try and be clear on a test or quiz so you don't waste time rationalizing. But in this one, it matters to me that it's rationalized. So Gabby told me it's 1 over root 2, which is perfect. How do I rationalize that? Good. Multiply top and bottom by square root 2. So I get root 2 over root 2 times root 2 is root 4, and square root of 4 is 2. I also just think when you rationalize it, you're just left with the number that's in the radical. Okay, so that's my sine. What's my cosine? The same thing. You can write 2 root 2 because you did all the work already, or you can do the workout again if you want to prove to yourself why that works. But cosine and sine are the same in a 45, 45, 90 triangle. And then what's tangent going to be? 1. Very good. Now we're going to flip them all. So if sine was 1 over root 2, cosecant is root 2 over 1. Well, anything over 1 is just itself. So that's redundant. I'm just going to write it as root 2. Secant is also just root 2. And then cotangent 1 divided by 1 is the same thing. It's 1. The whole purpose of what we did here, though, was to get sine and cosine. So I'm going to put a little box around that because that was the crux of what we did. I think it's important to do a complete job. So that's why we did all the rest of them. But the whole point I'm trying to prove is with sine and cosine. All right, questions on this one? We're going to do this for the 30 and the 60 too. Are we still looking at it or can I move on? Okay. I'll keep it big in case anyone's doing it, but because first I'm going to do is fill in my ratios. Does anyone remember the 30, 60, 90 ratios? It's okay if not. The side across from 30 is always 1. The hypotenuse is always 2. And the side across from 60 is always root 3. Same thing with the other shape, it's just flipped. So now my 1 is still across from 30, but now it's on the bottom, it's not on the right. My hypotenuse is still in the same place, so 2 is in the same place. And then across from 60 is my root 3. All right, now I'm going to zoom in and do my sine, cosine, tangent, cosecant, secant, cotangent of all of those. So you can also, I will zoom in just so you can't see that in a second. You can fill in yours. All right. Sine, cosine, tangent, cosecant, secant, cotangent, and then sine, cosine, tangent, and then cosecant, secant, cotangent. All right, I just set myself up. I'm ready to fill in. Are you guys ready to fill in? Okay. What's my sine of my 30-degree angle? Nope. 1/2. Even easier. I guess I forgot to label these. Remember, 1 is opposite, 2 is hypotenuse, and then √3 is my adjacent. So sine here is simply just 1/2. What's cosine? √3/2. Good. And then what's tangent? 1/√3. Again, I do want us to get comfortable rationalizing in these special right triangles. So 1/√3, if we rationalize that and multiply by √3 on top and bottom, it becomes √3/3. Once we've done the math once, now we won't really ever do the math again. We'll just remember that 3√3 is important, and √3 and all those things are kind of important. Flip everything to get the second column. So 1/2 flipped is 2. √3/2 flipped is 2/√3, which again we will rationalize by multiplying by √3 on top and bottom. So 2√3/3. And then cotangent, I'm glad Gabby had told me that it was 1/√3 first, because now it's easy to flip that. 1/√3 flipped just becomes √3/1, which is just √3. And again, we did all this hard work to just get sine and cosine. All right, now we're going to do 60, and we're going to notice a pattern in a second. Any questions so far? Okay, you guys are doing great. I know this is a lot. Sine here, because I'm now focusing on 60, my opposite is at √3, my adjacent is now 1, and my hypotenuse is still 2. So sine in this case is not 1/2, this time it's √3/2. Cosine is my 1/2. If you just stop and pause right now, sine of 30 is the same thing as cosine of 60. Also, cosine of 60 is the same thing as sine of 30. So that's a nice little hint we can keep in our heads. In the 45, 45, 90, the cosine and sine are the same. In 30, 60, 90, they are opposite of each other. So sine of 30 is the same thing as cosine of 60. Cosine of 30 is the same thing as sine of 60. I'm just noticing patterns and bringing you with me. Tangent is going to be √3/1, which is just going to be √3. And then everything flipped. So if I do √3/2 flipped, it's going to be 2√3/3. Secant of 60 is going to be just 2. And then cotangent of 60 is going to be √3/3. All right, we did all of this background work to fill in the front side. So we're going to just see how much we can fill in on the front side. Is there any questions you have for me right now? Okay. We did this so we don't ever have to do this again. When I was talking about the daily quizzes, it's knowing these trig functions. So like I should be able to see you in the hallway and say, what's sine of 60? And we're going to know what that is. I can say, what's cosine of 45? Like we should know what that is. And what I'm about to teach you is a way of organizing our thoughts that I think is the clearest way to know these things the easiest. Instead of drawing a triangle each time, this unit circle is going to help us know that. So when I say the word unit circle, the word unit means that like my radius is only 1 unit. It means that even though this looks like a long distance, my radius all the way around is only 1 away from the axis at all times. So like from here to here is 1, from there to there is 1, etc. And let's actually fill that in first. So if you notice there's a lot of blanks, we're going to fill in, we're doing the quadrants first. So we're doing like the like x-axis and the y-axis. So we're going to fill in these little coordinate points first. I think that'll make the most sense. I did not do that last period, so sorry, F period, if you're watching. My bad. So I just told you it's the unit circle. So like what would this point out here be? We went over 1 unit and we didn't go up and down. What coordinate point would that be? 1, 0. So I'm going to put 1, 0 in that like ordered pair area. What about if I went, I'm just working this way around my triangle. So what if I went here? What if I went up 1 and didn't go left or right any? 0, 1. What if I'm over here and I went left 1 and didn't go up or down any? Very good. And then that negative y-axis down here, where I just went down 1, I didn't go left or right any. 0, negative 1, very good. Okay, now that we have the coordinate points there, we're going to put angles with these. Remember yesterday we were doing everything from north and we went like worked around this way? What sucks is I teach you bearing and then now I'm about to like kind of reverse that on you. We're not starting from north anymore. We're starting from 1, 0. We're starting from standard form of my angles. All of my angles will have one of their sides be on the positive x-axis. So we're always starting here. And then our angles are going to move counterclockwise from there. If I'm starting on that yellow line, that positive x-axis, that's where my 0 degrees is going to be. That's where 0 degrees is. What if I go from the positive x-axis up to the positive y-axis? How many degrees have I gone then? 90. I'm going to put that on the degree line right here, 90. What if I go all the way from the positive x-axis to the negative x-axis? 180, very good. What if I go from the positive x all the way to the negative y? 270. And then what happens if I went from the positive x-axis all the way back to the positive x-axis? 360, very good. Okay. If you notice next to every degree mark we just did, there's another line. On that line, we're going to fill in the radians. There are important special radians that we're going to just know because they go with important special degrees. Remember the other day on the board when we, just yesterday, I guess we did our degrees, radians, all that stuff. And I said, the biggest thing you need to remember is pi radians is equal to 180 degrees. Remember when I said that? That is important for right now. We just wrote 180 on the negative x-axis. So that's the same thing as pi radians. All of our special radians will be in terms of pi. They won't be like 1, 2, 3 radians. It'll be pi radians, etc. And I told you fractions were important. So if 1 whole pi is from 0 to 180, how many pi's would it be if I went from 0 all the way to 360? 2 pi's. Now next to 0 degrees, if it's 0 degrees, it's also 0 radians. So that's a whole number, no pi's or anything. Okay, let's break it apart even more. If from 0 to 180 was 1 pi, how much is it from 0 to 90? 1/2 of a pi. So we're just going to call that pi over 2. Fractions are about to become real fun in a second. And then how much would it be if I went from 0 to 270? 1 1/2. We're going to use an improper fraction. We're going to call it 3 pi over 2. So it's like 3/2 pi. We're right where I was with F period, but I'm going to set you up so then when we talk on Monday, it won't be so confusing. It's going to be a little tough for F, but they'll figure it out quickly, I'm sure. We're going to look at the first quadrant, so between 0 and 90 degrees. This line right here in the middle is halfway between 0 and 90. You good back there, Parker? That sounded like it hurt. What's halfway between 0 and 90 degrees? 45. So I'm going to put 45 right here. Now we're going to have fun with fractions. What's halfway between 0 and 1/2? Yeah, that would be in degrees. I want to know in fractions. What's between 0 and 1/2? a fourth. Whoa, fractions, it's been a minute. So 45 is the same thing as 1/4 pi, or pi over 4. Let's do the other degrees. This one's not maybe as noticeable, but between 45 and 0, the only other important angle we just talked about was 30. And then the one that's between 45 and 90, the only other one we talked about is 60. So all of these angles around here are multiples of 30, 45, and 60. Let's figure out what the radian is for my, actually, no, we'll do that online. The last thing I want to do is the ordered pair right here. When we do ordered pair, I want you to write this somewhere on your paper. I'm going to write it at the bottom. I'm going to write this. I'm going to write x comma y, and I'm going to write a little arrow, and I'm going to write parentheses cosine of theta, comma sine of theta. What that means is in my picture, the ordered pairs are telling me cosine and sine. The ordered pairs are telling me cosine and sine. So if I go to any spot on here, I'm going to know the cosine and the sine of it. What's the cosine and sine of 45? What did we just say on the other side? What was my cosine and sine of 45? They were the same. What's my sine and cosine of angle 45? Root 2 over 2. So I'm going to put root 2 over 2 as my first ordered pair. As we do more of this, we'll remember that root 2 and root 2 go with 45. And so then I will know that cosine and sine of 45 are root 2 over 2 and root 2 over 2. All right, that's good for today. We'll review that a little bit tomorrow on Monday because I haven't taught that to F period yet. And then we're finished filling this in. We'll get more notes. I am officially assigning your 4-1 homework though. That will be due on Tuesday. You can submit it online either day, or you can bring it to me in person on Tuesday. I know I do not see you on Tuesday. It is still due on Tuesday. Okay? I'm going to stop recording. If anybody needs this, feel free to go back and watch it.